Well, greetings, Mr. Colazar's class. We're going to continue now with our alkanes, which are going to be what we're going to be looking at drawing straight chain and branch chain alkanes coming up. But we're going to start with our straight chain alkanes. Now, alkanes are going to be ending in ANES, are going to be hydrocarbons that contain only single bonds. So we're going to look at two major versions of them. Our straight chain hydrocarbons in which all of the hydrocarbons are in a row. Now that doesn't mean that they have to be in a row. We could see that when we draw out the structure, it's actually going to zigzag around a little bit, but all of them are connected one next to each other or another. So if we had one carbon to another carbon down, as long as they're all connected one after another, that's going to be a straight chain. A branch chain is our second type. Branch chain, we have one carbon going to a second carbon, but now this carbon is connected to a carbon and this carbon is connected to a carbon. So we're saying that they have branched off from one another, going in different directions. So just like a tree branches, hydrocarbons can also branch. Now there is another one called cyclic that aren't on here. Cyclic would be if we had one carbon going to another carbon, going to another, and back to the beginning. Cyclic would make a circular shape. Well, it wouldn't have to be circular, but a connected closed loop shape. And so cyclic could be a third branch or a third version. Now, when it comes to naming our alkanes, straight naming, this is number 9 in your notes, it's going to be the organic prefix from your gold packet plus the word ane at the end. So ane is going to be added to what we call alkanes. So whatever organic prefix is, remember meth is 1 carbon, eth would be 2 carbons, prop 3, but 4, pent 5, hex 6, 7, 8, 9, and 10. And I would like you also right now to write this information in. So to write this down at the top of that page, it's just a simple, quick equation. 2n plus 2 gets us the number of hydrogens. And so if your hydrogen number, let's say, is 2, or maybe your carbon number, if you have 2 carbons, 2 times 2 is 4, plus 2 is 6. So if you have 2 carbons, you would have to have 6 hydrogens for that equation. And so it's going to be something that we're going to continue to see as we're going forward, is how to find the number of hydrogens if you know how many carbons you have by your organic prefixes at the beginning. So to start us out, methane is our first one. Molecular formula for methane is 1 carbon. Now 2n plus 2. If you have 1 here, 1 times 2 is 2, plus 2 is 4. So 1 carbon, 4 hydrogens is our molecular formula. Structural formula, remember we have each carbon bonded to 1 hydrogen to show our 4 total bonds for each carbon. That's what we're looking at there. And then our condensed structural formula is going to be kind of the same, CH4. That will start to change here in a little bit. Now ethane, 2 carbons for ethane, 1 carbon for methane. So 2 times 2 is 4, plus 2 is 6. So 2 carbons, 6 hydrogens from that equation up above. Now from there, our structural formula, we have 1 carbon bonded to a second carbon, and in each spot where we're not bonded, we must have, remember, a total of 4 covalent bonds, 4 covalent to each carbon. So in any spot where there's not a carbon-carbon bond, we're going to fill that with our hydrogen atoms. So there each has 4 covalent bonds. Our condensed structural formula, we have 1 carbon here that has 3 hydrogens, 1 carbon here that has 3 carbons. So CH3, CH3 would be what we're going to look at there. Now propane, 3, butane 4. So our molecular formula, remember 2n plus 2 is going to equal, here with propane, we would have 3 times 2 is 6 plus 2, so C3H8. So our structural formula, 3 carbons, each with a hydrogen bonded to each one. Now this time when we look at it, we'd have CH3, CH2, CH3. So that each of those carbons are represented there. Butane, C4, 2 times plus 2, so 8 plus 2 is 10 hydrogens. If you want to, you could count them up each time. 1, 2, 3, 4, 5, 6, 7, 8 would get us the 8, and then here a second. 1, 3, 4, and just to help us out, we're going to imply that hydrogen is located here. So we won't have to draw them in coming up. Now when we look at this one, we have CH3, and then we have 1, 2 CH2s. So at this point we can start putting that in parentheses, and then finally a CH3. So this is where the condensed structure takes off, is from here we're just going to keep adding more to that middle chain. So as we'd continue along, pentane would be 5, 6, 8, 9, 10, and then our molecular formula, C5H12, remember it's 2N plus 2. So as we're looking or continuing on from here, we'd continue C6, H14, C7, H16, C8, H18, C9, H20, and then finally C10, H22. Sure, that's a 20. So structural formula would continue to increase by 1, and our condensed structural formula, now CH3, CH2 in parentheses, and now there's 1, 2, 3 of them, and finally CH3. And that would just continue to grow as we'd go down. From there, our structural chemical formulas. First off, skeletals are the shorthand means of drawing organic compounds. So when we look at each of these, this is going to be our shortcut way to draw them out. At the end of each line represents a carbon atom. So the end of each line represents a carbon atom. Each carbon atom is assumed to have enough hydrogens to attach to make our 4 bonds. So if we were to look 1, 2, 3, 4 carbons for butane, its actual ball and stick, our structural formula, we have 1, 2, 3, 4 with each hydrogen so that we'd have enough to make those 4 bonds. And how we would draw this out is we would have 1, 2, 3, 4. And what this would represent is the first carbon, the second, the third, and the fourth. So what we're looking at here is kind of a shorthand way instead of having to draw everything out. This is our skeletal structure shorthand way for drawing them out. Make sure we include this info in that number 10 in your notes. Now, using this organic shorthand, we're going to use the organic prefix to find the amount of carbon bonds that we need to have. So our first part, carbon always makes 4 bonds. So we're going to bond enough hydrogens to each atom. So when we look at that, butane, our first one here, chemical formula, C4 for butane, and then H10. So our structural formula, just keeps jumping on me, C4 with our 10 hydrogens, is now going to be shortened to the skeletal structure with just 4, 1, 2, 3, 4 zigzag, showing that each of these carbons would be the first, second, third, fourth. So at the end of each of those lines is what we're looking for there. Now as we move on, heptane, we're going to shorten this one up just a little bit. Heptane, C7, H2 times 2 plus 2 is going to allow us to just go 1, 2, 3, 4, 5, 6, 7. And I'm just going to just show the lines, implying that there's a hydrogen at each one. But easier is going to be a skeletal structure 1, 2, 3, 4, 5, 6, 7. So in the end, this is going to be our new structure for heptane. Now continuing on, just the opposite will be the naming of our. So we're going to count each carbon atoms to determine the organic prefix, and then use all single bonds, remember, end in ane. So 1, 2, 3 would be propane. Chemical formula C3, counting our hydrogens, H8. So propane, remember, has 3 carbons is where it gets that name from. Skeletal structure, down, back up. Remember, this would be our first carbon, our second carbon, and our third carbon would be those 3 located there. From there, our next one we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbons is nonane. C9 times 2 plus 2 is 20. So if we wanted to, 1, 2, 5, 6, 7, 8, 9, and we would have enough hydrogens in order for it to be all completed. So that's going to be our shortcut when it comes to naming and writing these compounds out, known as our skeleton structure.